Question 2. Solve the equation cosecant squared theta plus 3 cos theta minus 4 equals 0 over the interval from 0 to 2 pi. Express your answers as exact values or correct to 3 decimal places. So this is a quadratic trig equation. It is quadratic because of the squared, and it is, of course, trig because of the cosecant. Because it is a quadratic equation, we want quadratic equations to equal 0, and this does, so we don't have to move any terms around. We could leave it as is. To solve quadratics, you usually factor, so we need to factor this quadratic. In order to factor this quadratic, we want to multiply to get negative 4, and we want to add to get positive 3. The combination we're looking for would be some combination of 4 and 1, and because we want to get a positive 3, we would need a negative 1. So to quickly factor this, it would be cosecant theta plus 4 times cosecant theta minus 1. And of course, this still equals 0. Don't forget that. So we're going to solve each of these factors. And solving the first factor, we get cosecant theta equals minus 4. And cosecant theta equals 1 for the second factor. The way I prefer to solve reciprocal functions like cosecant is to change it in its primary function. So the reciprocal of cosecant is sine. So I'm going to take the reciprocal of the left side. If I take the reciprocal of the left, I must also take the reciprocal of the right. The reciprocal of negative 4 is negative 1/4. And the reciprocal of cosecant, again, is sine. The reciprocal of 1 is 1. So in order to solve this equation first, we must find the reference angle. We cannot use our special triangles for this because 1/4 is not found in our special triangles. So we will end up having to resort to our calculator. This is the symbol I use for reference angle. My reference angle will be my inverse of 1/4. And I have to put this into my calculator. So I'll bring my calculator over. I want to make sure my mode is radians, and you can see that it is. So that's good. And now I will go second function sine in brackets 1 divided by 4. Close my bracket, and I get a reference angle of my reference angle is 0.25268. 25268. Although my final answer needs to be 3 decimal places, I should keep more decimal places at this point. I also will use a storing capability. So I'm going to store this answer under the variable a, just to keep that stored. So the ratio is negative. So we want to worry about where sine is negative. Sine is negative in quadrants. Well, let's see. All students take calculus. So sine's positive in 1 and 2, so sine is negative in 3 and 4. So we want to find those values. So theta in quadrant 3, right? The start of quadrant 3 is pi. So we want to go pi plus our reference angle. So I will go pi plus my reference angle, which I stored under a, and I get my first solution to 3 decimal places. Now it's appropriate to round 3.394. My quadrant 4 solution is going to be 2 pi minus. The end of quadrant 4 is 2 pi. just move this over here for now. The end of quadrant 4 is 2 pi, so 2 pi minus my reference angle. So 2 pi minus 25268. And I'll do that on my calculator. We'll go 2 pi minus my reference angle, which I stored under A. And I could be assured I'm getting the right decimal accuracy. So my theta here is 6.03. And now this is tricky, but it's a 5, so we better round this up to 1. All right, so that is it for that one. Now the next one, I still have to solve sine theta equals 1. This is a little easier to do, right? If you remember the unit circle, sine is the y-coordinate in the unit circle, right? So sine is y-coordinate. So we're asking, where is the y-coordinate in 1 when we're in the unit circle? Well, where are we a height of 1? This is the only place we're at a height of 1. So the solution to this is pi over 2. So those are our 3 solutions for this problem. Solution 1, solution 2, and solution 3. I'm just going to double check and make sure they don't want general solution. The original question said 0 to 2 pi, so we are doing fine. All right, so again, here are my 3 solutions.